Welcome back to lecture series on linear control systems. This is the 11th lecture, and in this lecture we are covering RH stability criteria, which comes under module 3 in our syllabus. And in last class we were discussing about RH stability criteria in general. We did some simple problems also in that. But anyhow, it may not be that simple in all cases. Generally, what we were doing, we were preparing a tabulation column by using the characteristic equation, and we were inspecting the first column elements of that characteristic equation. Then if there is any sign change, what was our conclusion? Yeah, please memorize that. If there is any sign change in the first column, then we conclude that there should be some right hand side poles. Whenever there is poles in right hand side, again we know that it indicates instability. There is some unstable condition. Okay, that's clear. So if the first column elements are, suppose an example, 1, 2, 2, minus 2 and 1. I will repeat, 1, 2, 2, minus 2 and 1. These are the first column elements in RH stability criteria, RH tabulation. Then how many sign changes are there? 1, 2, 2, minus 2 and 1. Is it 1 or 2? That was the important thing, or that was the area where mistakes may happen to you. So if you have doubts, please refer our last video, lecture 10, so that there is two sign changes when you are changing to 1, 2, 2, minus 2. From you are changing to plus 2 to minus 2, it is first sign change. And then you are changing from minus 2 to plus 1, it is another sign change. So you are having two sign changes. That indicates two poles are there on right side. And there was one more important thing. I was checking whether there is any poles are located on the middle axis. What is the middle axis? Consider XY plot. What was the middle axis? That was imaginary axis. In the problem that we discussed in last class, I said that poles on the imaginary axis is 0 in all problems. Why so? What was the indication for presence of poles in the imaginary axis? Please recap. If there is any poles on the imaginary axis, there should be some 0th row in the tabular column. In last class, in all of our problems, all the rows were non-zeroth rows. So we can simply conclude that no poles are there in the j omega axis. That's why we can simply calculate how many poles are there on the left side, because we already got how many poles on the right side by inspecting the sign change. Then also there is no poles on j omega axis. Then total poles minus poles on the right side will give you poles on the left side, like that. So up to this we were recapping our last lecture. Now we are going to today's topic, RH stability criteria, special case 1 and 2. Special cases are always cases where we can't simply move, or we can't simply proceed the tabulation work further. It will block somewhere. We will face some point in which we can't proceed the tabulation further, or we can proceed the calculation further. Such two cases we have to discuss in today's class. Okay. I will go to the details. RH criteria, special case 1. Okay. In special case 1, what happens is some element in first column will become 0. We want to check whether it is positive or negative. We want to inspect all the elements in first column whether it is positive or negative. But if some element becomes 0, what we will do? If some element becomes 0 in the first column itself, we can do the further proceeding because there is two difficulties. One is about the sign, and the second one is, that is the most important thing, in calculation for finding the next element we can divide by 0. Generally we are dividing with the elements, in each step we are dividing with the element of first column, and if some element of first column becomes 0, something divided by 0 will tend to infinity. So that is the case. If some element in the first column becomes 0, we can proceed the tabulation work further. You can see here. In this case where one of the first column element becomes 0 in the RH tabulation table. Tabulation cannot be performed after that. What is the remedy for? We want some remedies. Okay, tabulation cannot be proceed means we can't stop there. We have to find the stability. We have to inspect it. So we should have some remedies. So what is the remedy? Remedy means we have to replace the 0 with a very small positive value. Suppose 0.001. It is a positive value that is approximately equal to 0 itself. So we can say it is a small value that will tend to 0 in the upcoming future. So we are replacing 0 with that epsilon. This is epsilon, you can see here. This is the notation of epsilon. And then you proceed the calculation. Anyhow, from example it will become more clear. Now don't be confused. By doing the examples we will get more clarity. So anyhow, when 0 appears in first column, you just replace with a epsilon. Epsilon is not a value, but say it is a value. It is having some small positive value which is very close to 0 or which tends to 0. Okay. Now we are doing a problem. Then only you will get a clear picture of this case 1. Characteristic equation of a Planck transfer function is s raised to 5 plus 2s raised to 4 plus 3s cube plus 6s square plus 5s plus 3 is equal to 0. Find the number of right side poles. They are not asking you to find whether it is stable or not. On the same, it's having the same meaning, but they are asked with some other way of questioning. Find the number of right side poles. Okay, if there is right side poles, anyhow the system will be unstable. So I have written the characteristic equation one more. Actually in this problem transfer function is not given. What is characteristic equation? If transfer function of the Planck is given, how you will find the characteristic equation? If transfer function is given, take the denominator of the transfer function and equate that to 0. That will give the characteristic equation. So s raised to 5 plus 2s raised to 4 plus 3s cube plus 6s square plus 5s plus 3 is equal to 0 is nothing but denominator of the transfer function equated to 0. Okay, anyhow, while getting some transfer function or characteristic equation, what is the first step we have to do? Before applying RH stability criteria, we have to check two conditions. First condition, check whether all the coefficients are having of same polarity. We can see 1, 2, 3, 6, 5, 3. All the coefficients are positive. So first condition is satisfied. And second condition, there should not be any missing coefficient. S raised to 5 is present, S raised to 4 is present, S cube is present, S square is present, S is present, and S raised to 0, that is its coefficient is 3, constant. All the coefficients are present. Then both conditions are satisfied. Now we can apply RH stability criteria. Okay, I have arranged the things in RH stabilization form because S raised to 5 is the higher degree, its coefficient is 1, and alternatively S raised to 3 is the next one, its coefficient is 3. Then S raised alternatively you have to take all odd only, S raised to 5, S raised to 3, S like that. So 1, 3 you will get, I will highlight it, 1, 3, 5 in the first row. Then in the second row, that is row of S raised to 4, you have to take 2, 6 and 3. 1, 3, 5 and 2, 6, 3. This is the first step. Then what is the second step? You have to find the elements corresponding to the row S cube. For that you have to apply our basic calculation, that is nothing but, I will repeat once more before going to the problem, because this is the first problem we are dealing today. That's why I am recapping. After this problem I will not repeat this again. So please listen. 2 into 3 minus 1 into 6 all divided by 2. That is the first element. What will be its value? What will be its value? Please check. 2 into 3 is equal to 6. 1 into 6 is also 6. Okay. Divided by 2. So 6 minus 6 divided by 2. What is the case? Here it comes. 6 minus 6 divided by 2. 6 minus 6 divided by 2. That is equal to 0. Then we can say we have to replace that 0, because if that is 0, how you will find the first element of next row? 1 minute, sorry, let me make it flight off. Okay. So if you are not doing any remedies, how you can find the first element of S squared row? Because you are in that row you have to cross multiply and divide it by this element, that is 0. So you can proceed further. That's why you are replacing 0 with a small value epsilon. So take it as epsilon itself. Next time you will get 6 into 5. Sorry. Next row means 2 into 5 minus 1 into 3 by 2. That is 10 minus 3 by 2. That is 7 by 2. Okay. And the third row, automatically there is no elements after that. So because you are if you want to find the third element, you have to multiply this 2 with the 0. So that will become 0. And this 1 with some 0 here. Here also it is 0. So anyhow that will become 0. So you replaced 0 with epsilon in the third row, and now you are going to find the fourth row. I will explain once more. As this is epsilon, you have to do epsilon into 6 minus 2 into 7 by 2 by epsilon. 6 epsilon minus 2 into 7 by 2 is 2 itself. 6 epsilon minus 7 by epsilon. So how we can simplify that? What is the value of 6 epsilon? I know that epsilon is very close to 0. That's why 6 into that very small value will give that total time 6 epsilon approximately equal to 0. That's why I can neglect that element. then it will become minus 7 by epsilon. But you can neglect the epsilon in the denominator. Be careful. So that is equal to minus 7 by epsilon. On the other hand, what is the second element in the S square row? Please do the calculation like this. Epsilon into 3 minus 2 into 0 all divided by epsilon. Please repeat. Epsilon into 3 minus 0 by epsilon. So 3 epsilon by epsilon, that will give 3 itself. That's why second element is 3. And third element automatically it will be 0. Now what will be the last row? Please do the calculation. Minus 7 into epsilon into 7 by 2 minus 3 epsilon by minus 7 by epsilon. That will be a bigger thing. Yeah, like this. Anyhow, don't solve that. Please kept like that only, because we just want to know whether it is positive or negative. That is the only thing we want to find from that. That's why don't waste time on solving such things. Anyhow, we should be able to check whether it is positive or negative. That is the case. So what is the second element? Second element, you can see that automatically will become 0, because this into 0 minus epsilon into 0. That's why this element will become 0, and the last element also will become 0. Now, please check the polarities of elements in the first column. 1, it is positive. 2, that is also positive. And 0, that is replaced by epsilon, and we are assuming that epsilon is small positive. So, third element is also positive. Fourth element is minus 7 by epsilon. Definitely it is negative. Minus 7 by epsilon. So, fourth element in the first column is negative. Now, what about the last element, s raised to 1? It is simply logical. You can see minus 7 by epsilon into 7 by 2. That will be a negative term. Minus 3 epsilon. So, the numerator will be a negative term divided by minus 7 by epsilon. So, numerator is negative, denominator is negative. Then it will be a positive value. Then the ratio will be a positive value. So, the last element is positive. I will mark it like, sorry. Actually, that was the s raised to first row. I have to do one more row. I'm sorry, s raised to 0th row, and that will I will solve it. How you will get the 3? That is my question. Anyhow, 3 is given here. I will explain the step. This value into 3 minus this into 0, all divided by this itself. That will give 3. And 0, 0. Remaining elements will be 0 and 0. So, 3 is positive, simply positive. So, we got that 1 is positive, 2 is positive, epsilon is positive, minus 7 by epsilon is negative, and the big term, this element, that is also positive, and the 3 is positive. So, I will mark like it. Positive, 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 negative, positive, positive. Okay. How many sign changes are there? Now, you know how to conclude about sign change. As it is changing from positive to negative, it is change 1. And again, it is changing from negative to positive, it is change 2. So, there is 2 sign changes. That indicates 2 poles are there on right side of j omega axis. Okay, and let me ask, is there any 0th row? Any row is completely 0? Please check. No. No entire row is a 0th row. That's why if there is at least one 0th row, we have to check how many poles are there on j omega axis. That we will learn later. But up to the moment, as there is all the rows are non-zeroth row, then no chance for poles to be placed on j omega axis. So all the poles are either on left side or on right side. How much poles are there? What is the total number of poles? We have to check the degree of characteristic equation. As the degree is s raised to 5, fifth order equation, then there should be at least there should be 5 poles. And in that 5, 2 poles are placed at the right side. Then how many poles are on the left side? Remaining 3 will be on left side. And the question is nothing but how many poles are there on right side. The answer is clear from this point itself. 2 poles are there on right half plane. Now we will move to the conclusion. Total number of poles 5. Number of sign changes in the first column, that is 2. So number of poles in the right half plane, again 2. Number of zeroth row, no zeroth rows are there. So no poles in j omega axis. Number of poles in j omega axis is equal to 0. Then number of poles in the left half plane, how you will get? You have to take the difference of total poles minus poles in the right plane. So that is 5 minus 2 plus 0. What is the 0? J omega axis poles. No poles are there in the j omega axis. Then the poles in the left side is 3. Anyhow, the system is unstable because there is 2 poles on right side. So this is the special case 1. So once again I am repeating, when the special case 1 happens, when some element in the first column becomes 0. Okay. Okay. Now we are moving to RH criteria, special case 2. Okay. This is the thing in the last topic, special case 1, last problem, last slide. I told you that we will discuss it later, whether when some row become entire elements will become 0, we will call it as a zeroth row. If zeroth row is there, there may be poles on j omega axis. That is the knowledge that we are having till the moment. But on this case, we are going in detail to that statement. If a zeroth row is present, that is not exactly talking that poles are on j omega axis. There are some other poles also. Sometimes these poles may be on real axis also. Generally it will not happen. Generally that poles will be on imaginary axis. And if some pole is on is present on imaginary axis, its conjugate will be present on that axis itself, because for example s square plus 4, what are the roots? Please think. S square plus 4, what are the roots? S square is equal to minus 4 and s is equal to plus 2j minus 2j. In all those combinations we will get plus 3j minus 3j, like that. Conjugates are present. That's why such poles are symmetrical about imaginary axis or symmetrical about origin, because this is the origin, plus 2j is here, minus 2j is here. With respect to the origin, these are symmetrical. And in some problems, we may get plus 2 and minus 2. That may be also present. We have to check that. We can simply say there are some poles on imaginary axis. In last problem we can say, because in that problem no zeroth row is present. That's why no options are appearing like this. It is clear that there is no poles on j omega axis. But now we have to check how many poles are there on j omega axis. Is there some other possibilities also? Because in this case we are facing some zeroth rows. So when sum of the odd number row becomes zeroth row, that is a important thing. In RH stability criteria, only odd rows will become zeroth row, like s raised to 5, s raised to 3, s raised to 1, like that. Only odd rows will become zeroth row. Then tabulation cannot be proceeded. All the elements will become 0. How we will do the tabulation? Then take the row just above the zeroth row. If s raised to 1, that row is zeroth row, please take s raised to 2 or s squared row and form an auxiliary equation from that row. It is the equation. What is auxiliary equation? Please read that statement. Then take auxiliary equation. It is the equation formed from the row just above the 0th row. So how you will form the auxiliary equation, such things, it will become clear while doing problems. Anyhow, by checking that row above the 0th row, you can form auxiliary equation. Then differentiate auxiliary equation with respect to s, and you will obtain some coefficient from the differential. Put that coefficient instead of 0th row. Then it is no more a 0th row. Anyhow, your s raised to, for example, your s raised to 1 row is 0th row. You take s raised to 2 row or s squared row and form an auxiliary equation. Differentiate that auxiliary equation with respect to s, and you will get some differential term. And in that also there may be an s term, and take the coefficient of that and substitute instead of 0th row. Now it is not a 0th row. Now you can proceed the calculation like that you done earlier. But what is the physical significance? If a 0th row is present, it indicates presence of a pole in the j omega axis. It is a normal case, but it may not be like that only. There are other options, abnormal cases also. Roots of auxiliary equations are the poles placed in j omega axis. Okay, this is the normal case. I am explaining the normal case. Presence of imaginary axis means, presence of 0th row means there are chances for poles on the imaginary axis. Then you know there are some poles on the imaginary axis, but you don't know the exact value of that poles. So if you want to find the value of that poles, please solve the auxiliary equation. You got some auxiliary equation previously. You please solve that. Find the value of s from that auxiliary equation. Then you will get the exact value of poles. For example, s raised to 1 row is 0th row, s square row is auxiliary equation. This equation is having two roots because s squared row means second order, two roots. And in normal case that two roots will be in the form of plus j omega minus j omega. You can mark it like this. You can mark it like this. This is the normal case. There is one more possibility. It is, you should consider it as an abnormal case. In such a case, your answers or your value of s will be real terms, not imaginary terms, plus sigma minus sigma. But its magnitude will be same and its polarity will be different. So you can mark it like this. Suppose it is plus 2 and minus 2. You can mark it like this in the real axis. Now also you check the both the figures are symmetrical with respect to origin. I am not mentioning any axis. I am not mentioning symmetrical about real axis. I am not mentioning it symmetrical about imaginary axis. I am just saying that both these figures are symmetrical with respect to origin. Is it right or wrong? Please check. This is origin. This is origin. Is these two poles are symmetrical with respect to this point? Yes. And in this case, this is origin. Is these two poles are symmetrical with respect to origin? Yes. So with respect to origin, these poles are symmetrical poles. So generally, we can say if a 0th row is there, there are poles on imaginary axis. But it will not be like that always. The exact statement is that there are symmetrical poles with respect to origin. That is the correct statement, because it may not be imaginary poles in all cases. There are some chances where poles may be real also, but that real poles are symmetrical with respect to origin. Suppose last case I told you that auxiliary equation is s square plus 4 is equal to 0. So s is equal to plus 2j minus 2j. Now let me tell auxiliary equation is s square minus 4 is equal to 0. Same thing, s raised to first row was 0th row. You are checking auxiliary equation and you get the auxiliary equation like x square minus 4 is equal to 0. Then what is the value of s? Plus 2 and minus 2. But that is not happen in normally. Normally poles will be having an imaginary term like plus j omega minus j omega. Anyhow, don't get confused. We will clarify these things better in problem session. So now we are moving to a problem. Transfer function is 1 by s raised to 5 plus 4 s raised to 4 plus 8 s cube plus 8 s square plus 7 s plus 4. Check the stability. Okay, now all of you know how to mark the coefficient in R. Anyhow, before going to this, you have to check the condition 1 and 2. I forgot to write there. Condition 1 and 2 are satisfied. You know that. No coefficients are missing and all the coefficients are positive. No sign change. So 1 and 2 are satisfied. Now you arrange the coefficient in RH tabulation criteria like alternately 1, 8, 7 and 4, 8, 4. You arranged it. I will repeat if you want. 1, 8, 7 alternate coefficient in the fifth row, and the fourth row 4, 8, 4. So as it is a fifth order equation, you have to start from s raised to 5. S raised to 5 and s raised to 4 you have to write directly from equation. Then you have to do calculation. So what is s raised to third, s cubed equation? 4 into 8, 4 into 8 minus 1 into 8 by 4. 32 minus 8 by 4. 24 by 4, that is 6. Okay. And what is the second element in s cubed row? 4 into 7 minus 4 by 4. 28 minus 4 by 4, that is 24 by 4, again 6. And third element, as there is no elements further, third element will become 0. 660, that is the case. 660. Now what is the squared row? 6 into 8, I will tell. 6 into 8 minus 4 into 6 by 6. Okay, 6 into 8 means 36, 48 minus 4 into 6, 24 by 6, that is 24 by 6, that is 4. And like similarly the next element is 4 and the last element is 0. Up to this moment everything is fine. You are very familiar with these steps. No need to explain like this. Okay. You please check what is the next row. Let me check. 4 into 6, 24, minus 6 into 4, 24 by 4, by 4. 24 minus 24 by 4, it will become 0. Immediately don't take 0 that is equal to epsilon, because now you don't know it is case 1 or case 2. Please check the other element also. Then you can make sense when then you can conclude that it is case 1 or case 2. What is the next element? Let me check. 4 into 0 minus 6 into 0 by 4. Normally that will become 0. And the third element also will be 0. So this is the 0th row. S raised to 1 is the 0th row. All the elements are 0, which is a 0th row. Now you have to find auxiliary equation. Auxiliary equation is the equation obtained from the row just above the 0th row. So you have to inspect s squared row. 4, 4, 0. What is the s term related to this 4? Before that, let me ask, what is the s term related to this 1? It was s raised to 5. It obtained from s raised to 5. What is the term related to this 4? From characteristic equation, it was 4 s raised to 4. Like that, what is the s term related to this 4? It will be 4s square. And what is the next element? Next element mean alternate degree we are taking. If you are confusion, let me explain. This is s raised to 5. This was s raised to 5 from characteristic equation. What was this? 8s cube. Alternate degrees are taken in the RS tabulation. Like that, these 4 represent, as it is a squared row, this 4 represent 4s square. And this 4 represents alternate degree. 4 into s raised to 1 or 4 into s raised to 0. S square is the first term, then the second term will be alternate mean s raised to 0. So that will become 4s square plus 4 into s raised to 0. That is nothing but 4s square plus 4. That is equal to 0. This is auxiliary equation. This is the procedure for forming auxiliary equation. You have to check whether that coefficient belongs to this which s term. Now differentiate that auxiliary equation with respect to s. We have to find some coefficient now. So that's why we have to differentiate that auxiliary equation with respect to s. So d by ds of 4s square plus 4. 4s square means this differential is 8s and 4 that is a constant 0. So 8s plus 0, that is the differential. Simply you can say 8s only. So 8s means you have to put 8 as a coefficient of s term. Anyhow, for putting that coefficient of or putting that value of 8 for term relative to s, you have to go back to tabulation curve. Before that, you please memorize the thing that 8 is the coefficient you obtained and 8s is the equation. 8s is the equation obtained after differentiating auxiliary equation and coefficient is 8. 8 is coefficient of which term? S term. You have to put 8 for the term corresponding to s or s raised to 1 in auxiliary in RS tabulation criteria. Please keep it in mind. Now I am going to locate where the poles are exactly. Anyhow, now you know there are some symmetrical poles with respect to origin. I have to check whether it is whether these poles lies in imaginary axis or not. For that, I am solving it because the auxiliary equation is 4s square plus 4 is equal to 0. For finding the poles, exact location of poles or exact value of poles, you have to solve auxiliary equation. Don't differentiate auxiliary equation. Differentiating auxiliary equation for finding the coefficient of s, that you should need to put instead of 0th row. But for finding the exact position of poles, you have to solve the auxiliary equation. That is 4s square plus 4 is equal to 0. 4s square is equal to minus 4. So s square is equal to minus 1. So s is equal to plus j minus j. It is the normal case. In normal case only such poles are appearing. You can draw like this the pole plot. You can draw the pole plot like this plus j minus j. So how many roots are there on imaginary axis? 2 roots are there on imaginary axis. These 2 roots are symmetrical with respect to origin. So please keep this point in mind. There is 2 roots which are placed on imaginary axis that we have to use in the final conclusion. So 2 roots out of 5, because it is s raised to 5, that is the higher degree of the equation. Out of 5, 2 roots are lying in the imaginary axis. Now move back to RS table. Before moving back to RS table, please memorize what was the equation you obtained by differentiating auxiliary equation? 8s. So 8s means the coefficient of s is 8. This is s. So this 0 should be replaced by 8. You got the point? It will become more and more clear if you are doing more and more problems. Suppose, okay, we will discuss more problem in next class, then no issue. Now this is the case, by differentiating auxiliary equation you got 8s. 8s means s is the term and 8 is its coefficient. So please check the auxiliary equation. The auxiliary equation is the equation representing s raised to 1, s. So its coefficient is not 0, it is 8. We obtain 8 from the differentiation. So substitute that there. Now you can proceed the calculation, because now first column element in the first column is not 0. So you can proceed the calculation further. How you can proceed the calculation? 8 into 4 minus 4 into 0 by 8. That is 32 by 8. Nothing but 4 itself. S raised to 0 through 4. And the other element will become 0. We have to check. I will explain. 8 into 0. Sorry. 8 into 0 minus 4 into 0 by 8. Anyhow 0. 0 and 0. So calculation is over. Now check, is there any sign change in first column? 1, 4, 6, 4, 8, 4. No sign changes are there in the first column. That means all the poles are located on left side. Is it correct? I am saying that no sign change. That means all the poles are lying on left side. Is it correct? No, it is not correct. If there is no sign change, you can say no poles are there on right side. But you cannot say all the poles are there on left side, because now you know, as there is a zeroth row, you got two poles are there on imaginary axis. Imaginary axis is neither left nor right. It is the middle axis. So we will conclude. Anyhow, the sign changes, I have marked the sign change. All the sign of first column elements are positive. So no sign changes are there. Total number of poles, that is 5. Number of poles in the right half plane, no sign change in the first column, so it is 0. No right half RHP poles, no poles are there on right half side. Number of poles in J omega axis, that is 2. Now number of poles in the left half plane, that is total number of poles minus poles on right side plus poles on imaginary axis. As poles on right side is 0, but imaginary axis is 2, the answer is 5 minus 2, that is 3. Now let me ask you, is it stable or unstable? Don't read that. Is it stable or unstable? If you are having doubts, please check the concept of stability, location of poles. If poles are located on J omega axis, we have to think twice. If any one of the poles are there on the right side, definitely system will become unstable. But it is not that case. Some of the poles are on the left side and two poles are there on the imaginary axis. So the system is marginally stable. Then you have to check one more thing. If the poles on imaginary axis are repeating, then system will become unstable. That is, if there is 4 poles on imaginary axis, plus 2j and minus 2j, then poles are repeating on same point on imaginary axis. 2 poles are there on same point. In such case, even though there are no poles on right side, then also your system will become unstable. That is the case. As poles are non-repeating and that they are present on J omega axis, you can now conclude the system is marginally stable. So this is the case. This is very important area for the exam point of view. RS stability criteria, case 1 and case 2. In next class also we may be discussing about RS stability criteria. I will check some more question papers, and I think we may be discussing this again, because some more problems with some small twists are there. We will discuss it later in next class, I think. Anyhow, this is an important area. But for making this area clear, before that you have to learn that well, concept of stability and location of poles. Then only you can conclude whether it is stable or unstable. Otherwise you can write 2 poles are there, 3 poles on left, 2 poles on right, some poles are on J omega axis. You can write that only. You can't say the final thing, whether it is stable, unstable or marginally stable. For saying that, you should learn that video lecture very clear. Stability from the location of poles. I think that was 9th lecture. Okay, anyhow, we'll meet in the next class. So you can ask your doubts and such things in the channel itself, or you can mail me or WhatsApp me. So we'll meet in next class. Thank you.